Welcome to fourth grade adding and subtracting fractions. First, we're going to review what third graders learned. In third grade, students decomposed fractions in multiple ways, and they really focused on unit fractions. Here you can see in third grade, our denominators were 2, 3, 4, 6, 8, and 10. And these are our denominators for fourth grade. Notice the new denominators that we're using in fourth grade are 5, 12, 25, and 100. So our fourth graders are coming to us with some good prior knowledge here. So first we're going to start off with a strategy that students worked on in third grade. And it's different ways to see how a fraction can be broken up into a unit fraction. So let's take 3/4. We can think of 3/4 as 1/4, 1/4, and 1/4. So then our equation would be 1/4 plus 1/4 plus 1/4 equals 3/4. Another way to see 3/4 decomposed is we can break 3/4 into 2/4 and 1/4. And then our equation would be 2/4 plus 1/4 equals 3/4. So we want students to be able to have that flexibility in the way that they break up those fractions into unit fractions. All right, so let's move into something that we're going to start with for fourth grade. Remember, we do not need to worry about teaching students to simplify at this point. We can stress that once we have taught them about equivalent fractions. Our denominators are like denominators only, and we are adding and subtracting fractions less than 1 as our whole number. Our sum can be greater than 1, but we're adding and subtracting fractions less than 1 whole. Okay, so here we're going to use some pattern blocks. If we think of this as our whole, we want to give students the opportunity to explore and to develop an understanding of what the fractional parts are. So we're going to give them some ample time to discover that if we put 2 pieces on, obviously that's halves. If we're putting 3 pieces on, those are our thirds. And continuing on, if I put 6 pieces on, then that's going to be my sixths. So if I have my problem, 2/6 plus 3/6. I now know through my discovery that I'm going to need these green triangles. So I have 2/6 plus my 3/6. And then students, so I'm going to write that down, 2/6 plus my 3/6. And then I can put those together and see that I have 1, 2, 3, 4, 5, 6. And when I think about estimation, I think about how that number 5, 6 is going to make sense because it's getting me close to that whole number. All right, so now we're going to move down and we're going to look at our problem, 3/5 plus 3/5. Now we're going to take our model and use a linear model. And if we're estimating, we're thinking 3/5 is almost, it's over a half, and another over a half, 3/5 more, would give me a little over a whole. So thinking about estimation before you start will help students to understand if their answer makes sense or not. So our problem is 3/5 plus 3/5. Again, we want to give students opportunities to make sense of the fraction bars. I know they do have numbers on them, but we want to encourage students to understand that it takes 5 of those pieces to make that one whole. So if I have 3/5 and then I add my 3/5 more, if I write that as a problem, I have 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5 plus 1/5. Now, I can take my whole and I can see, oh, look, it takes 5 of my fifths to equal 1 whole. And then I have 1/5 left over, so that makes my answer 1 1/5. I can also show this in a different way. I can show that 6/5, 1, 2, 3, 4, 5, 6/5 can be broken down into my 5/5 and my 1/5. So this gives me my whole number, 1, and then my 1/5 that's left over. Another way to see that. So a final way we can show this is by taking this bar model and transitioning it to a number line. Ooh. All right, so my number line is going to go to 2. And then I have fifths, so I'm going to divide each part into fifths. So that's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so I'm going to start at 3/5. Remember, in 3rd grade, students learned how to partition number lines, so this should not be too challenging for them. So I'm going to go to 3/5, 1/5, 2/5, 3/5. So that's where I'm starting. And then I'm going to add 3/5 more, so that's 1/5, 2/5, 3/5. And then you can see that I end up at 1 1/5. Now, some students, they'll need to make those 3 jumps. Some students can just do it in their head, 1, 2, 3, make that 1 jump to get them to that 1 1/5. All right, so here are some fractional circles. We just want to show you that you can also show this problem, go from a linear model to a circular model. So here are our 3/5 plus our 3/5. We can take them and put them together to see our whole and our 1/5. Okay, so now we're going to transition to drawings using our area model. Our problem is 7/8 minus 4/8. So I've taken some patty paper or paper that we can see through, and I've drawn my model of my 7/8 and my 4/8. And this is a great way for you can put it on top, and students can see that when I put it on top, those cross out, or I've taken those 4 away, and then this is what I am left with. So if I'm going to draw that, I have my 7/8. I'm going to take away 4 of those 8s, and I'm left with my answer, which is 3/8. All right. Now let's relate this to addition using just the equation. So my problem is, or let's relate this to the equation. My problem is 11/12 minus 6/12. So I know that if I have 11/12, thinking back to what I've done previously, and I take away my 6/12, that is going to leave me with my 5/12. I can also relate this to addition, and I can think, if I have 6/12, how many more do I need to get to 11/12? So I could write it like this: 6/12 plus how many more do I need to get me to 11/12? And that's where my 5/12 comes in.